Welcome explorers, welcome to the coding implementation part for the Playfair Cipher, which I had discussed about in the previous video on the introduction part. So in this video basically I am going to discuss about the Java implementation code for the Playfair Cipher. So without further ado, let's start the video. Now before discussing about the coding part, what I have basically written here, I would like to make a few announcements. So basically in this video I am basically going to discuss about only the encryption coding part by using the Java language for this Playfair Cipher. And the second announcement is that I am basically thinking of heterogeneizing my content, and basically I am not thinking of introducing different ciphers by different programming language. I am basically thinking of sticking to Java because I think that Java has a lot of unique features which other languages such as Python as well as C and C++ doesn't have. Although it would not be just to say that, because C is the parent language or the father language, you can say, for all the programming languages, and Python has much more unique features than all the other programming languages combined, and it also has a lot of popularity which it has gained in the recent years. So sorry for that, but I would like to stick to Java and discuss my cipher encryption techniques as well as decryption techniques which we have for the various types of cipher in this whole world by only using the Java programming language. So that is basically my aim for the rest of the videos which I will make in the future for any cipher. Now with that being said, I am basically going to explain the encryption coding part by using the Java language for this Playfair Cipher. So first of all, as you have already understood that this Java language, actually first of all, if you want to take an input from the user, then you have to write import java.util.scanner. So this is basically the parent class or the instance class, you can say, by creating the objects of which we are basically taking the input by using the scanner class. So now first of all let me tell you what basically first of all we are going to do here. So let me scroll down. So here basically, as you can see, sorry, this is the extra line of code, I have to delete this. Yeah. So now you can see that first of all the program or the control will shift over to the public static void main function. So inside this function I had first of all declared two string variables, plaintext or pt and key. So I had also taken the plaintext as input from the user by using the scanner instance, and I had basically taken the plaintext here in this line, as you can say, and after that I also taken the key as input from the user as well, and then I had closed the scanner instance of the object, and then I had passed on the plaintext as well as the key string variables to the encrypt function. So the definition for which is written above. So this is basically what I had actually done in the public static void main function. So basically everything is going to happen inside the encrypt function here. So unlike the rest of the code which I had written here, which I had written for all the ciphers which I had discussed in my channel until now, it is not like that. So this encrypt function is basically going to take all the inputs whatever is required, and it is basically finally going to print the encrypted text inside the encrypt function also. No case of returning is involved in this case. So inside the encrypt function, let me go to the top because it is a huge function, as you might have already seen. So the encrypt function is here, as you can say, static void encrypt and string pt and string key. So basically it is taking two arguments, plaintext as well as key. And now inside this function, as you have seen that first of all I had declared one ptr or plaintext character array equivalent of the plaintext string variable. So this is basically the instance to character array where the string variable will be converted into the character array format, where each of the characters present inside the plaintext. The plaintext string variable will be converted to the character format having each of the characters present inside the pt underscore arr. And then I had also done the same thing for the key string variable as well, and store it inside the character array key underscore arr. And then I had declared one character array called alpha, where all the characters or letters of the English alphabet are present, and the capital J is not present here because I and J are considered to be the same in Playfair cipher, because we have to finally make the table also. And after that, the character or the 2D character array has been declared by the name of table, which is basically going to be the reference table, which I had actually discussed in my previous video. And so it is basically going to be a 5x5 matrix or 2D character array. And after that, I had declared or basically initialized one character array called encpt_arr. So we will basically see what this character array does in the latter part of the code. And I had also declared integer encpt_arr_counter equal to 0. So these two things I will discuss later in the final part of the code, in the end of the function. So you will basically come to know what these two things does here inside this encrypt function. And after that, I had declared one integer control or counter variable, which is basically initialized to -1 here. And now the first thing which I had done in this part of the code is that I had basically I had gone by each and every character for I equal to 0 till I less than key_arr.length. So basically this for loop is going to iterate as many number of times as the number of characters which we have inside the character array called key_arr. So basically you can say that this is the character string having all the characters present inside the key. So basically in this code, what we are basically doing here is that we are basically trying to store each of the characters which we have inside the key character array inside the table. So as I already discussed you, if you have monarchy, then MONAR and CHY is going to get stored inside the table in the row wise fashion in the respective orders which they occur in the character array. And after that, what we have done is that we have again run a for loop, but this time it is going to run 25 times because it is having the number of iterations as 25, because the length of the alpha character array is 25, because 25 alphabets or letters of the alphabet are there, and for each of the characters which we encounter inside this character array called alpha, if it occurs in the key character array, then we are basically going to store that position or index by the character 0. So basically it is a dummy kind of thing. You will notice the significance of what I am actually doing here in the latter part. So here in this part you can see I am basically trying to store the remaining alphabets which we have inside the alpha character array inside the table. So basically all the characters which were actually utilized and already stored inside the table are not going to get stored inside the table 2D character matrix. So basically for doing that only, I had actually blocked all those parts where the monarchy or the letters of the monarchy were actually stored, and after that I had done the storing of the remaining characters which we have inside the alpha 2D character array, alpha 1D character array, and we had basically stored all the remaining characters inside the table which we have inside the alpha character array. And so this for loop is basically doing that only. Oh, it's okay. And sorry, this for loop is not doing that. Basically this for loop is actually going for the logic part, or basically forming the intermediate text. Okay, so the intermediate text I had written it here as character array, which is any, by the name of any, and this is basically the initialization for the intermediate text. And after that I had also declared one counter called intc equal to 0. I had initialized it to the value of 0, and basically this for loop, as you can see here, for each of the characters which we have inside the pt_arr character array, it is going to iterate as many number of times as we have the number of characters inside the pt_arr character array. So basically this is a huge for loop. We have a large number of if conditions here. So if you can go through this code, I am not basically going to explain each of the if conditions, but I can only tell you one thing, that for each of the characters it is basically going to execute the same logic only which I had declared in the previous video, where we have to go by each of the characters and consider each of the special cases for forming the intermediate text. So for example, if you have hello, then H and E are going to get stored inside the any character array as it is, but after that we have L and L. So L and L are same, so after that we have to store L and then X and then again L, but after that we don't have the same character, so we have to store O. So the final intermediate text will come out to be, after all these if conditions, after the specified if conditions for all the characters, we will come to the intermediate text. We will arrive at the intermediate text. So as you can see, I had become somewhat mad by writing all these if conditions, but that's okay, because I had got very confused when I was basically writing, but later for writing the if conditions I came to know about the pattern which I should follow. So after that things got a little bit easy for me, so I could write all these things, all these if conditions inside the for loop by making use of some logic. So I will provide this entire code in the description box. You can check that out if you basically want to go through all these code implementations as well as all the if conditions as well as the minor changes which you should try to configure by yourself only. And basically coding is all about configuring the simple codes by yourself. So there is no one which can actually explain you the entire piece of code. So you are the only one who can explain you the entire piece of code. So you should try to understand the code part by yourself only. So computer science is such a subject where you should try to understand the entire code by yourself. No one is going to explain you whatever you are writing. So if you have that logic, and you should try to develop or inculcate that logic also. So that is what I actually wanted to share with you all. So coding language does not matter here. So basically only if I am using Java and no other languages, that also doesn't make any sense, because Java is basically any type of coding language where ultimately you have to implement the logic also, and which is also the case for any other coding language. So that is not a factor. And so after generating the intermediate text, I am basically printing the intermediate text, and this small if condition, as you can see here, is very important, because in the intermediate text one condition which I forgot to mention in the previous video is that you must have even number of characters in the intermediate text. So if you don't have even number of characters, that is the CIF which denotes the final count of the number of characters in the intermediate text at that time, if it is odd, then you have to append or add one extra capital X at the end of the character array. So that will basically end up for an even number of characters inside the intermediate text. And after the intermediate text is generated, you are going to print it as it is. So basically we are doing that here in this code snippet. And after that, what I am doing is that I am basically going for the logic part. So after generating the intermediate text, we are basically focusing on generating the encrypted text. So after generating the intermediate text, I am basically focusing on to generate the encrypted text directly. So for doing that only, I am running this for loop, which is going to run the number of times as are the number of characters inside the intermediate text. Okay. So for this for loop, as you can see here, the if condition which we have here is the very important piece of code, because this for loop, the remaining code inside this for loop which I am going to explain it to you, is not basically going to detect any j, because I is the only one which is present in the table 2D character matrix. So for that only, if any j prevails inside the intermediate text, I am going to replace it then and there with capital I, and the same goes for the second character for each of the pairs also. So as you can see, for each of the pairs we are going to execute the for loop. For example, if you have 6 characters, then this for loop is going to run 3 times. and if you have 8 characters, this for loop is going to run 4 times. So basically for each of the iterations we are going to handle each of the pairs of characters. So for that only we have to take care of each of the characters which we have in each of the pairs. And after that I am going to declare integer row 1 equal to 0, row 2 equal to 0, column 1 equal to 0, column 2 equal to 0. And so after that, basically what this for loop will do is that it will basically store the row 1 as well as the column 1, that is the row and column value for the first character present in each of the pairs, and the second for loop is going to store the row as well as column value inside row 2 and column 2 for each of the second characters present in each of the pairs. And after that we are basically going to check if the two letters belong to the same row or not. If they belong to the same row, then we have to increment or go to the right side of the column by 1 unit. So as I had already discussed with you, this is the second rule probably, I guess. And after incrementing 1, you have to check whether you are going to implement the wraparound condition or not. So if it exceeds or goes out of the condition or scope, then you have to write modulus 5, because this will basically keep you in the same column. And the same goes for the column 2 as well. And after that you are basically going to O. So here it is the encbt underscore ARR. So this is basically the character array or 1D character array for storing the encrypted letters. So and this is also the same counter which is basically going to keep track of the counter where we are going to store the encrypted characters. So for each of the inclusions inside this character array, we are basically going to plus or increment the encbt underscore ARR underscore CTR counter variable. So for each of the pairs, as you can see, the first, if you are basically going by this condition, that is row 1 equal to row 2, then we have to write this, and the first the character which we have found by doing these two pieces of code, you have to map this inside the table 2D character array, and the same goes for the second pair as well. So I hope that you are understanding what I am trying to convey through my speech. And let us come to the else if condition where column 1 equal to column 2, that is if the characters are present inside or belong to the same column. So you have to increment the row value by 1 because we are going down, and also the wraparound condition is also there to satisfy your wishes, and the row 1 equal to row 1 plus 1 modulus 5 and row 2 equal to row 2 plus 1 modulus 5. So after that we are basically going to do the same thing, increment the counter and store the necessary values by mapping the row 1 and column 1, row 2 and column 2 values inside with respect to the table matrix. And the else if condition, here again we have another else if condition where it is not belonging, where the characters do not belong to the same row as well as the same column. So if that is the case, then we have to basically declare one row as well as column value and store the row as row 1 and column equal to column 2. So basically here what we are trying to do is we are basically trying to form a rectangle or square, whatever, as discussed in the previous video, and for each of the corner elements, that is the remaining two corners, we are basically going to go by the respective fashion and map the row as well as column value with respect to the table 2D character array and store the necessary characters which we have got inside the encbt underscore ARR character array. And the same goes for the second character as well, and the else condition doesn't have anything because these three are the only cases which are possible for the arrangement of the letters for each of the pairs. And after that the reference table is printed because the user would also like to verify whether he had got the same encrypted text or not. So for the convenience only the reference table or the 5x5 table is printed, and after that the encrypted text is finally printed. So no need to return anything because it is of type void. The encrypt function here is of type void and not string. So no need to return any string or any other kind of variable. and it is not accepting any string or variable, other kind of variable also. So let us now run the code and see what happens. So I am basically going to write the same things which I had declared, which I had discussed with you in the previous video on the explanation part. So the first one was the plain text was the plain text was jazz. So let me write it, and the key was as usual monarchy. So now let me expand this. So the plain text was jazz and key was monarchy. The intermediate text is JAZXZX. So as you can see, the intermediate text is right, and the reference table is monarchy and the remaining characters of the English alphabet. Okay, and so finally the encrypted text is SBUZUZ. Okay, so the encrypted text was also correct, as we had seen in the previous video, as we had done manually the encryption. And now for your convenience as well as satisfaction, let me run it once again and enter the second plain text, which was hello, and the key was as usual monarchy. So the intermediate text is HELXLO, and the reference table is same, and the encrypted text is CFSUPM. So the encrypted text was also correct. So now let me run for another, that is the conventional one, welcome explorers. So that is what I am implementing for all the previous, welcome explorers. So that is the conventional as well as the traditional plain text which I have been using for all the encryption as well as testing the encryption techniques as well as decryption for all my previous ciphers, right? So with that being said, now welcome explorers, yeah, it is correct. And after that you enter the key monarchy. You can enter any other thing, whatever you want. So the intermediate text is here because it doesn't have any repeating characters much, only this 2 is here. It is going to add one extra X here, as you can see, and after that everything is quite similar. But after that, until this one, we have encountered odd number of characters. So for making it even, we are basically adding one extra X. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so even number of characters, it is fully justified. And the reference table is monarchy and the remaining characters. So the encrypted text is here, as you can see. So it is completely unreadable and quite troublesome if anyone wants to decrypt this encrypted text without having the reference table as well as the intermediate text or key. So we had finally accomplished our mission. So that's all from the encryption part for this Playfair Cipher. Guys, I hope you enjoyed this video. If you really enjoyed, as well as had seen the entire video and have come up this far, then you deserve a huge amount of praise. So thanks for watching this video. I hope you enjoyed this video. If you enjoyed this video, then don't forget to give it a like and also subscribe to my channel for further interesting updates. So I will meet you next time. Until then, keep exploring.